We are going to answer some checkpoint questions. And this is the first one. It reads, a fair 1 to 6 dice is thrown. That means it's a legit dice. It's not a fake dice in the sense that it's not going to be used for cheating. It's actually so that it's numbered from 1 to 6 and you don't have, let's say, the number 4 appearing twice. Let's say other side and other side for cheating. So that's what a fair dice means. It says that we should draw a line to match the event to the mutually exclusive event. What does it mean by things being mutually exclusive? Now let's see. So as you can see from this definition over here, it says that mutually exclusive events are events that cannot happen at the same time. In other words, if one event happens, the other must not happen. So they are events that we don't expect to see the same numbers in, basically. So let's go back to our question. So I'm going to list the members of this event over here. An even number is thrown. This event, I'm going to list its elements. So I'm going to, even numbers on the dice are 2, 4, and 6. So I'll just list them down quickly. Let me get my pen. So 2, 4, and 6. It means that we are going to be matching it to the numbers that, or the events over here that don't have 2, 4, or 6 in them. And as you can see, if I match it to this 2 over here, 2 is thrown. It's not going to be exclusive to this since 2 is also over here. If I match it to 2 or 3 is thrown, as you can see, there is a 2 here. There's also a 2 here. So they won't be exclusive. But if I match it to the 3 is thrown, I can see there is no 3 over here. That means that this event and this event will not happen at the same time. I can't match it to this because 4 is over here, 4 is over here. Then the last one is even just as likely to happen. It looks just the same, 2, 4, 6. So that means that the only mutually exclusive pair of events over here is an even number is thrown and 3 is thrown. The second question says, Ben has 2 fair spinners. 2 fair spinners again, meaning that they all have the same probability of occurring. Each section has the same probability of occurring. A. What is the probability that he will get a 5 when he spins spinner A? So we have to, first of all, write out the probability. So we have to look for the total number of elements in spinner A. As you can see, there are 1, 2, 3, 1, 2, 3, 6 elements in spinner A. How many 5s are in spinner A? 1, 2, 3, 1, 2, 3. There are no 5s in it. That means 0, 5. So the probability of getting 5 when you spin spinner A is going to be 0 out of 6. You can also write it in percentage, which is 0%. B says, I am more likely to get an odd number when I spin spinner B. Explain why he's wrong. He's wrong because, let's look at spinner B. The numbers are 1, 2, 3, 4, 5, 6. And it's talking about more likely to get an odd number. So let's calculate for the probability of an odd number. So probability of odd probability of odd numbers for spinner B, that's going to be out of the 6, I'm going to get 1, 2, 3 odd numbers, which is basically 50%, which also means that the probability of an even number over here is also going to be 3 out of 6, which is also 50%. So explaining why he's wrong. So this is going to be my explanation. He's wrong because the probability of getting an odd number is the same as the probability of getting an even number. So it's no more likely to get an odd number, and we've done the calculation here. Probability of odd number is 3 out of 6. We could also do the calculation for the probability of getting an even number. So probability of getting an even number, we have P to bracket even, and as we saw on the spinner, we have 3 even numbers, 2, 4 and 6. So it's also 3 out of 6. Now let's answer one more. This one is quite interesting personally. Here are 4 bags of balls. So I have this bag A, B, C and D. It says Blessed takes a ball from each bag without looking. Complete this sentence. The likelihood of taking a black ball is the same as the likelihood of taking a white ball in a bag. So it means that in one of the bags, the probability of taking a black ball is the same as the probability of taking a white ball. In other words, the number of black balls is the same as the number of white balls. So I'm just going to check the balls to see, I'm going to check the bags to see the ones that have the same number of white balls as black balls. So I have 1, 2, 3, 4. 1, 2 black balls. 1, 2, 3. 1, 2, 3. Same number of black and white balls. And I'm going to check the other ones just to make sure that the answers are, I've covered all my bases, and I've checked if even if in case there are more than one answer to this. So 1, 2, 3, 4, 5 white balls, 1 black ball, not the same number. 1, 2, 3, 4, 1, 2, 2 black balls, 4 white balls. So it looks like the only bag that has the same number of black balls as the number of white balls is the second bag. So my answer for this is going to be B.